Hello again, we're still in Geometry, Unit 2, Section 2-2, Biconditionals. This is video 3 of 4. I'm going to take a look again at another conditional and see if we can turn this into a biconditional. So the conditional is if two angles are congruent. So two angles are congruent would be our hypothesis. Then the two angles have equal measures. So there is our conclusion. So is that statement true or false? That statement is true. It's impossible to have two angles that are congruent and not have the same measure, because that's kind of what congruent means, is they have the same measure. Let's write the converse of this statement. So if two angles have equal measure, then the angles are congruent. Lots of abbreviation in there to shorten the video. So we took the if, we took the then, and we switched them to write the converse. So now we ask ourselves, is the converse true or false? So if we read this again, is it possible for us to find two angles that do have the same measure that are not congruent? No, that statement's true. So if we have a true conditional, the conditional is true, the converse is true, we can now write our biconditional. So here we go. We're going to write if and only if in the middle of the phrase. We're going to drop the if, we're going to drop the then, and the hypothesis and conclusion will be separated with if and only if. Doesn't matter which one you write first. You could write conclusion if and only if hypothesis, or hypothesis if and only if conclusion. I'm going to write the conclusion first this time, but it's really irrelevant how you want to write it. So we have two angles have the same measure if and only if, that's the key phrase, the two angles are congruent. And again, I mentioned this earlier in the videos for this section, but really what we're doing with biconditionals is we're writing definitions. Good definitions can be written as biconditionals, meaning there is no counterexample to the conditional or the converse that build that biconditional. So really when we're writing out this biconditional, we are defining what it means to be congruent.